All right. Welcome everyone. So as I said in class, I wanted to do a few more of these cross-section problems. We left off with this circle that had square cross-sections, and this was the integral that we came up with. Now you could just plug, you could just plug this integral at the bottom into your calculator and solve straight from there. But let's say that you had to do this by hand. Probably an easier way to rewrite this, because this is symmetric about the origin or about the y-axis even, we could make this from 0 to 5 and just multiply the whole thing by 2, right? Because if we get half of the integral and we multiply it by 2, then we're going to get the other half. So there's already a 4 out here. So if we just multiply this whole thing by 2, it becomes 8/25 minus x squared dx. And that integral is much easier to take by hand, as I'm sure that you would agree with me on. So I'll leave you to take that by hand. The final answer is 2,000 divided by 3. 2,000 over 3. So if you want to run through that and just verify that is what you in fact get, I do recommend that. Okay, let's take a look at this next problem, B. Section these two problems off. Okay, so B is it's the same thing. You're given this circle. The base is a circle, and the cross sections are triangles. And if you remember, I pulled up this picture in class where the base was a circle and we had triangular cross sections. And it says that the hypotenuse is along the base. So it would look something like this. So an isosceles right triangle. So these two sides, the two legs are equal, and they make an isosceles angle right there, right? So these two sides, we'll call this S and S, are equal. Now, one thing I want to refresh your memory on with right triangles, if one leg is X and it's isosceles, this leg has to be X, which means that this leg, think about your special right triangles, 45, 45, 90. It's x squared plus x squared is 2x squared. Take the square root. It's x root 2. Okay, so you can get that using the Pythagorean theorem or just by memorizing your special right triangle relationships. So this side down here then, which is the base, this is s root 2. We should probably be careful. This S here is different from this S here. Kind of wish we called it something else. We'll refer to it as the base. So the base is S root 2. And so what we need to figure out, what this S is. Okay, so we know that this is the base. So S root 2 we'll say is equal to B. So then S is equal to B over root 2. Right? All right. And B, if we look over to the left here, that's what this is equal to. Right? That's what we're calling B now. So B, the base, is going to be equal to 2 root 25 minus x squared. Okay, so the area of our base of this 3D object, we know it's 1/2 base times height. The base of this, we can say, is S. We can call this the base and this the height, because whenever we stand this up on its side, you have base and height. So base, height. And I realize we're using that term base kind of interchangeably. If you're confused about this at all, please bring this up tomorrow. I'm kind of like rotating the triangle in my mind as I'm talking about this. Okay, so the area of each triangle is going to be equal to 1/2 times the base times the height, which is just S times S. So B over root 2 times B over root 2, right? Which is equal to 1/2 times B squared over 2, which equals B squared over 4. So this integral is -5 to 5 of, let's see, we already said that B is 2 times the square root of 25 minus x squared, that quantity squared, over 4 dx. If we take that integral, well, we can actually rewrite that integral. So let's do that first. It's the integral from -5 to 5 of, this is 4 times 25 minus x squared all over 4 dx. Those 4's cancel out, and we can do the exact same thing that we did in the last problem. So these 4's cancel out. And we can say, because this is a circle and it's symmetric about the y-axis, we can say 2 times the integral from 0 to 5 of 25 minus x squared dx. All right, and again, I'll let you run through that integral. You get an answer of 500 over 3 as your final answer. All right, and then last but not least, actually, no, I want to do a few more problems. So I don't say last but not least. But this problem, last thing in this problem is rectangles with height 4. So again, remember, got our circle. And we said that this distance, which is the base of our 3D object. Remember, b was equal to the, we said 2 times the square root of 25 minus x squared. Right? So, rectangles of a height of 4, we just take the base and we multiply by the height, because the area of a rectangle is equal to base times height. In this case, the base is 2 root 25 minus x squared times the height of 4. So it's 8 square root of 25 minus x squared. All right, and our integral, so we get the volume is equal to the integral from -5 to 5 of 8 square root of 25 minus x squared dx. Plug that into your calculators and you get about equal to 314.59, which is the same as 100 pi. All right. Let's take a look at the next problem. This says, consider the function f of x equals 6 cosine of 3x. Write the equation of the line tangent to f of x at x equals pi over 2. Well, the first thing we need to remember, this is a tangent line. We need a point and we need a slope. So we're going to find the point. F of pi over 2 is equal to 6 cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0, so 0. And my point is pi over 2, comma, 0. Now I need a slope. To get my slope, I need to take the derivative of f. The derivative of f is 6. Let's see, the derivative of cosine, -6, right? Because the derivative of cosine is negative sine. So -6 sine of 3x, chain rule, times 3, which is equal to -18 sine of 3x. Right? So then my slope at pi over 2 is -18 sine of 3 pi over 2. Sine of 3 pi over 2 is -1. So our slope is -18 times -1, which is positive 18. And our equation is y minus 0. It's 18 times x minus pi over 2, using the point slope formula. Okay, easy enough. Thought it'd be a good idea to go over that, since that was a problem on our test that we seemed to struggle with a little bit. All right, in B, it says find the volume of a solid whose base is bounded by f of x and y equals 0 from x equals 0 to x equals pi over 6. The cross sections perpendicular to the x-axis are right triangles with height 3. The other leg of the right triangle is along the base of the figure. So this triangle is oriented slightly differently than the last triangle we made up. Okay, draw our picture. What do we have? 6 cosine of 3x. That would look something like this. All right. And to figure out where that point is right there, that the x intersection, I should say, we are going to say 6 cosine of 3x equals 0. Cosine of 3x equals 0. Take the inverse cosine. The inverse cosine of 0 is equal to pi over 2. Divide both sides by 3, and x equals pi over 6. So this intersection point right here is equal to pi over 6. All right, and the area, so it already says our cross section is a triangle, so we know it's 1/2 base times height. And now this distance here is our base. So the base is equal to the y value. So the y value is 6 cosine of 3x. The question is, what is the height of this triangle? And it's given to us. It says that the height is 3. So A is just 1/2 times 6 cosine of 3x times 3, which is our height. All right, we can simplify that to be 9 cosine of 3x. And now we're just going to set our integral from 0 to pi over 6. So we're finding the volume. From 0 to pi over 6 of, remember this is area of the base, which is 9 cosine of 3x dx. If we were going to do this by hand rather than on our calculator, we would have to do u substitution. What would u be? Think about it. What would you set u equal to? You're right, 3x. Good job. The derivative is 3 dx, which means dx is du over 3. Substituting everything in. That 3 divides with a 9, and you're left with 3. Oh, plug in your values. This goes from 0 to, let's see, what's 3 times pi over 6? It's 3 pi over 6, which is pi over 2. Cosine of u du. All right. The integral of cosine of u is sine of u. We're going from 0 to pi over 2. So this is 3 times sine of pi over 2 is 1, and sine of pi over, or I'm sorry, sine of 0 is 0. So our answer is just 3 times 1, which equals 3. All right, and that's it. That's where I'm going to leave you. Make sure you come to class with any questions if you have any. We can spend some time talking a little bit more about these cross-section problems if you're still a little bit confused while we review for our tests on Friday. All right, have a great rest of your day, and I will see you all tomorrow. Thanks for watching.